Spend all week on this. So I'm going to break it into small chunks and build our way through the week. But we are going to start in 7.5 with something called a periodic function. And the definition of a periodic function is it is a function that returns to the same, and I need you to put y values at regular intervals. So, in a periodic function, you can pick any point on the graph, and then if you trace it, it returns and then repeats that pattern. But it has this starting y value, and you could pick, I could have chosen down here and done that. And then the period length is the distance between two consecutive maximum points or two consecutive minimum points. So on this one, do you see I can go from 1 to 5? That period length is 4 units. Let me repeat that. The period is the distance between two consecutive maximum points or two consecutive minimum points. The equation of the midline is a horizontal line that passes through the middle of the graph's max and minimum. So let's go ahead and talk about the max and minimum. The maximum y value is 2. The minimum y value is 0. What's halfway between 0 and 2? 1. So my equation, it's a horizontal line, and I can even draw it like this. So the midline is y equals 1. The amplitude is the vertical distance between the midline and one of the extremum points. Extrema are max or mins, okay? So then this is the distance, the vertical distance from the maximum to the midline is 1. And we abbreviate amplitude with amp. And it's a distance, so the distance is always positive. You can't have a negative distance. So this is a lot of new vocabulary. So you want to spend a little bit of time tonight. The homework is pretty short. Will take you maybe 15, 20 minutes. So spend a little bit of time working on vocabulary. Again, the period length is a horizontal distance from one maximum till it repeats that maximum. The equation of a midline is a horizontal line that passes exactly halfway between the max and the min points. Amplitude is the vertical distance between the midline and either the max or the min. All right, be careful. Not every graph with a repeating pattern is a periodic function. In example 2, why is this not a periodic function? Yeah, Jared? Awesome. Okay, this does not return to the same y values. It does have a pattern, doesn't it? It's got a nice looking pattern, but periodic is not just a pattern. Yeah. No, it's got to return to the same y value. So do you look at my introductory one? Do you see where the red dot is? I'll come back to this, but do you see the red dot? Yeah. And then it comes back to that. I was just saying like that. It's got to be to the same y, not x. All right, so in example 3, there are 4 graphs. It says, and actually all 4 of them are periodic, okay? They all 4 are periodic. So what I want you to do is I want you to draw a midline halfway through the max and the min, draw that horizontal midline, and then I want you to sketch a period. And you can start at a maximum and sketch just one period length, or start at your minimum. It does not matter which you choose. So in case you're having difficulty getting started, here's what I mean. The midline is a horizontal line that goes halfway through the max and the min. And then here's what I mean, and again, you could start at a maximum, or let me show you, you could have done this, where you started at the minimum, like either of those does one period length. So here's a period length, there's my midline. Here's the midline, here's a period length. Does that make sense? What I mean by a midline is halfway through the max and the min. And a period length, I typically start at a maximum and go to the next maximum, the highest. And that does the job for me. In example 4, it says, what is the amplitude of this periodic function? Amplitude is the distance from the midline to the maximum. So what I need to do is I need to draw my midline first. The equation of the midline is y equals 0. Then my amplitude is the distance, the vertical distance. Now be careful on this one. Do not assume tick marks. Let me repeat that. Do not assume tick marks. Do you understand that this is saying 2 ticks is 0.5? We're not going by 1, so pay attention. The tick marks are not always 1, and that's why it's important when we eventually get to you graphing, you've got to indicate your tick marks, because they don't always go by 1s, it depends. So then what is that distance from 0, y is 0, up to that maximum? It's not 1. It's 0.5, right? 2 ticks is 0.5. So it's going from y is 0 up to 0.5. So my amplitude is 0.5. Then the period length is how long does it take before it repeats? So I'm going to start, and I think this one's a little bit easier to do if you start at the origin. So do you see I'm actually starting on the midline? You can do this as well. It's how long does it take on the x-axis, a horizontal distance, until it repeats. It's not quite at the 6. Do you see it's a tiny bit beyond the 6? You remember the string activity we did? And as we were measuring how many around, and we got like, it was a little more than 6, so it's got 6.1, some said 6.2, 6.3, and then we discovered all the way around a circle was a very specific number. What do you think this 6-point number is? Yeah, Jared? It's 2 pi. It's supposed to be 2 pi. It's like 6.28. So the period length is 2 pi. All right, so before we move on, here's the big idea. A periodic function is a function that repeats and comes back to the same y value that you started with. Amplitude is the distance from the midline to a maximum or the midline to the minimum. A midline is a horizontal line halfway through your max and min values. And the period length is how long horizontally it takes until it's going to repeat. All right, so now what we're going to end up spending our week doing is graphing sine and cosine functions. And then we're going to do the parent functions today. And then as the week progresses, we're going to do all the transformations we did this year. Left, right, up, down, stretch, shrink, flip. So we're going to apply all of those apply to this. So here we go. Remember, here's our unit circle, and you remember that each x coordinate is cosine theta, and each y coordinate is sine theta. Remember, I had us go around the room repeatedly and keep saying that. It was because that's really, really important. So watch what I'm going to do. If I want to do y equals sine theta, those are the y values. So let me show you how we're going to fill in the table. The sign of 0 is 0. If I go to pi over 6, the sign of pi over 6 is the y coordinate, 1/2. If I want the sign of pi over 4, it's the y coordinate, square root 2 over 2. And if I want the sign of pi over 3, it's the y coordinate, square root 3 over 2. And then I left sign of pi over 2 is the y coordinate 1. I'm going to pause a moment and let you fill in the rest of the table. So all you're doing as you go around the table is filling in your y values. So then that's a square root 3 over 2, square root 2 over 2, 1/2, 0. And I'm going to keep going, negative 1/2, negative square root 2 over 2, negative square root 3 over 2. Keep going. There we go. The good news is we don't have to plot every single one of these points. What we're going to do is we are going to plot the 5 main points. So the 5 main points are 0, pi over 2, pi, 3 pi over 2, 2 pi. And you either use the big table or you can use your quadrantal values on your unit circle. So we know those already. So the sign of 0 is 0, the sign of pi over 2 is 1, the sign of pi is 0, the sign of 3 pi over 2 is negative 1, and the sign of 2 pi is 0. So you either get that off of your circle or they're right here in our table. Okay, but these are called the 5 main points. You don't ever need to memorize them, but what's going to inadvertently happen is you're going to remember them because we're going to use this so many times. But personally, I don't memorize them. I know on my unit circle, if I know those 4 points going around, because 0 and 2 pi are the same, I just know what I have to remember is that the sign of theta is my y coordinate around the unit circle. So if I know that, then I can do everything else. All right, what I'm going to do is I'm going to change my scale, and I'm going to make every 2 ticks a 1. And what I'm going to do now is I'm going to plot the 5 main points. So I have 0, 0, pi over 2, comma 1, pi, comma 0, 3 pi over 2, negative 1, 2 pi, comma 0. Now this is called the sine curve, and it's not V's. Make sure you're not making lines between these. These are nice curves, and how I'm getting those is because if you're graphing radical 3 over 2, and then square root 2 over 2, and then the 1/2, it's making this nice rounded curve, okay? So now what you can do is once you have the 5 main points, can you tell the period length is from 0 to 2 pi, so the period is 2 pi, Where's my midline? Good job. Y equals 0. What's the amplitude, the distance from the midline to a maximum? 1. The maximum is 1 and the minimum is negative 1. What I'd like us to do then is, this is a pattern that's going to repeat forever to the right and forever to the left. Since we have a little bit of space, let's continue the pattern to the left. So it'll go down, then 0, then up and back. And then what I want you to also do is add little arrows at the end, because this doesn't stop. Okay, this does not stop. It does continue forever to the right and forever to the left. Now, what math concept is it called when I'm considering how far left and how far right a graph goes? Does anybody remember? Yeah, domain. All right, so let's connect this. So we're getting back to some graphing information. So my domain is negative infinity to infinity. What's it called when I talk about the y values, the domain or the x values? The range. So what is my range here? It doesn't go up forever and down forever. Negative 1 to 1. Let's talk about the x-intercept. Oh my, I see it's crossing the x-axis a bunch of times. So what I want you to do is kind of stay with me here. Jot this down and then let's think about it. So do you see that this is going to be hitting every high value that's an integer? Not every number, not every real number, but every 1, 2, 3, 4, but 0, negative 1, negative 2, negative 3, negative 4, and so on. So we can say the x-intercepts are n times pi, where n is an integer. This might be a little bit new for you to see something like this. So I hope you understand that by the end of Algebra 2, we're starting to introduce a little bit of pre-calculus is kind of the objective of Algebra 2, where you're headed. So n times pi, where n is an integer, that gives me all of them. Now the y-intercept, there's only y-intercept, right? It's at 0, 0. Now, I want you to do something for me. You know how you can lock your iPad so that it won't move when you turn it? I want you to lock your screen, and then I want you to take your iPad, I want you to look at the graph, and then I want you to turn your iPad upside down, rotate it 180 degrees. And I want you to look at that graph and look at mine. What does your rotated graph look like? The same, right? And if you remember, when we talked about graphing, this is called origin symmetry. When you can take your graph and rotate it 180 degrees and it looks the same, this is also an odd function. So this is going to be important, maybe not for this course, but for your next course, and if you're going on to calculus eventually in high school or in college, we need odd functions. Odd functions help us do something called integration, and we can make our lives easier if we understand symmetry about the functions. So the sine curve is an odd function. All right, questions on this. This is the parent function for y equals sine theta. Have you ever looked at graphs where you've seen maybe in a newspaper, online, like temperatures. The temperatures over the course of a year, if you plot all the average temperatures over 365 days, they make a sine curve. If you like going to the beach, you have, what is it called, low tide and high tide. Those are sinusoidal. So it's really, there's a lot of real-world applications to trigonometry and graphs. All right, so now what we're going to do is we're now going to focus on y equals cosine theta. Again, I'm going to get you started. This will go a lot faster because now we sort of know what we're doing. If I have y equals cosine theta, I am interested in the x values around the circle. So the cosine of 0 is 1. The cosine of pi over 6 is radical 3 over 2. The cosine of pi over 4 is square root 2 over 2. The cosine of pi over 3 is 1/2. And the cosine of pi over 2 is 0. Go ahead and finish the table. Don't forget that you have that maze. You've had 5 days to work on the maze. It's due tomorrow. I've gotten about half of them. And then you will also, though, have this homework, but this homework should take 15, 20 minutes, not too bad. All right, so I'm going to finish this one as I go looping around into the second quadrant. That's negative 1/2. Negative square root 2 over 2, negative square root 3 over 2, negative 1. You notice the pattern with these? Kind of cool. And then it goes positive in the fourth quadrant, which should make sense. And all I'm doing is the x-coordinates as I go around. All right, so then what we want is we want the 5 main points for cosine. And the 5 main points are the quadrantal values, in case you're wondering like where those numbers were coming from. The 5 main points are the quadrantals. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Well, then I'm just going to look either at my unit circle or this table of values. 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. On the y-axis, let's go 2 ticks is 1. And then we're going to plot these 5. All right, here we go. 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi 1. So do you see that it really is, the period length is 2 pi. The equation of the midline is y equals 0. My amplitude is 1, my maximum is 1, and my minimum is negative 1. Let's go ahead while we're here and continue the pattern to the left. Just make sure you're not making it look pointy like a V. It's not a V, these are nice rounded curves. Because this does continue, it's not going up. So at the ends, you're going to round it down and put a little arrow. Can you see what I mean right here? That's the maximum. So then it's rounding and coming back down on each end. My domain is negative infinity to infinity. My range is negative 1 to 1. The x-intercepts are the same as before. They're at, oops, sorry, they're not the same. Let's take a look at where these are. This is pi over 2, 3 pi over 2, there's a negative pi over 2, negative 3 pi over 2, and then there's a whole bunch of them. So let me explain how you find these. What is the distance between pi over 2 and 3 pi over 2? It's not 3. What would you add to pi over 2 to get to 3 pi over 2? No. Pi over 2 plus 3 over 2 doesn't add up to 3 pi over 2. Pi, right? Pi over 2 plus pi, or plus 2 pi over 2 adds up. So watch how you're going to write this one in general. And again, I'm not testing you on the x-intercept. I'm just trying to plant some pre-calc seeds here. I would write it like this. Pi over 2 plus pi n, where n is an integer. I just want you to have seen this before so that next year, those of you going into Algebra 3, pre-calculus, the math applications and interpretations, any of those courses you go into, this will just help you. Hopefully it'll click a little better, I think a second year into it. The y-intercept is 0, 1. Now, if you take your graph and flip it upside down, it's not going to look the same. So it does not have origin symmetry, so it's not odd. So the other option was even. And what I want to draw your attention to is, do you remember when we graphed parabolas, y equals x squared? Remember it was a U shape. What kind of symmetry did the parabola have? Here? Yes, it had symmetry across the y-axis, and that's what determined even functions. So when you look at cosine, do you see that if I were to fold this graph on the y-axis, the right side would map onto the left side? So the cosine function has y-axis symmetry, which makes it an even function. All right, that finishes